All right, this is problem number 3 from final exam review number 2. It's asking us to, given this picture and that angle 1 is equal, the measure of angle 1 is equal to the measure of angle 3, and that P is parallel to Q, that's our given. We're trying to prove that L is parallel to M. All right, so the fact that P is parallel to Q, that tells us that these two lines are parallel. And I begin to think about what we had done previously with our little rivers. Saying if those are parallel, then those are like shores of the river. Okay. And then what does that tell me about angle 1 and angle 2?
They are both in the river. Well, angle 1 is in the river and angle 2 is out of the river.
Good. So what's the relationship? What do we call that?
Corresponding.
Very good. I'm going to say that angle 1 and angle 2 are corresponding angles. This was given. And why do I get to call them corresponding angles? Because that's their name. Definition of corresponding angles. Now, why is this helpful? Is there anything I could do that would say if parallel corresponding, is that ringing bells?
Yeah.
So parallel corresponding, and what's the third thing? Transversal. Then what? Parallel corresponding transversal. And the angles are what?
Then congruent.
Good. So our hypothesis is these 3 parts. Have we said parallel?
Yes.
We have. Have we said corresponding?
Yeah.
We have. Have we said transversal?
Yeah.
No. So what's the transversal here for angles 1 and 2?
Sorry, I forget. My mind's blanking on the definition of transversal. I'm so sorry.
That's all right. It's like the bridge that crosses over the river, and it's creating both of these angles.
Right.
So it's L is our transversal.
Okay.
L is transversal.
That would be the definition of transversal.
Very good. Okay, now that I've got all 3 of these facts and evidence, that means I've satisfied my hypothesis. Therefore, I can go on to the conclusion. What is it I'm going to say is congruent?
A measure of angle 1 is congruent to measure of angle 2.
Okay, I'm going to leave off the measure because we're going to use proper notation here, right? Angle 1 is congruent to angle 2. The fact that you said measure is actually important, and we'll get to that in just a second, but that's not what we use with congruence. That's what we use with equality. Now, this chunk was all about building this fact. The other fact we were given was that the measure of angle 1 is equal to the measure of angle 3. That was given. And with these 2 pieces of information, can you combine them?
Yes.
Okay, what happens?
If measure of angle 1 is equal to measure of angle 3 and measure of angle 1 is equal to angle 2, then is angle 3 also equal to angle 2?
Okay, I'm going to write it as you said, angle 3 equal to angle 2. Is that notation correct?
No.
No. So if we want to talk equals, we should put measures in front, right?
Right.
But I like this. Okay, what's my reason for this?
Substitution.
And when we do substitution, we always say substitution. Property
Of equality.
of equality. Excellent. I love that you used equality because we're using equality here. And we had equality in this contributing fact. We don't have equality here. We have congruence here.
Right.
So before I move on to this, I have to adjust this a little bit. If 1 and 2 are congruent, doesn't it lead directly to saying that measure of 1 is equal to measure of 2? Yeah, and you could either say definition of congruent angles. If angles are congruent, then their measures are equal. And if their measures are equal, then the angles are congruent. Definition of congruent angles. Or if you forget that, you could just say, if angles are congruent, then their measures are equal. As an if, then that'd be fine. So now we've gotten to this idea that 3 and 2 are congruent. 3 and 2. And our goal is to get that L and M are parallel. And now we've got 3 and 2 are congruent. Does that help us?
Yes.
Why?
Because they create a vertical angle in
Close, but not vertical. Vertical have to have the same vertex.
substitution.
No,
Wait, no. I'm so sorry.
that's all right. So we know that we're going to end up down here with L is parallel to N. That's our final goal, right? And that means that our final reason is going to be if something, then parallel.
Right.
Only way this can work is if our conclusion here is this. So what kind of theorems do we have that say if something, then parallel?
Sorry,
It's all right.
it's been a while.
I understand. That's why these are final exam reviews. They're taking us back. What kind of angles are 3 and 2?
When you put them next to each other, they can create 180. Wait, no.
Well,
Vertical angle.
so vertical angles would be like this angle 2 and this angle up here. Those are vertical.
Here.
Here's here's the bridge, the transversal. Are they on the same side of the bridge or on alternate sides?
Alternate. So
And are they interior to the river? Because now our river's going this way.
Right.
Or exterior to the river.
one. Oh wait, so we
This is
switched
the river.
to this.
Yeah, that's what.
Then alternate interior angles.
Good. So let's say that. Let's say that angle 3 and angle 2 are AIA. What's our reason for that?
Definition of.
Good. We call them AIA because that's what they're called. And now we know that if AIA, not enough.
True, we need other stuff.
Oh, but don't we basically have that these angles are congruent? And we know that this says if AIA are congruent with transversal, not as important, then parallel. So let's do the same thing we did earlier. We said that 3 and 2 are equal. Doesn't that mean that we can say angle 3 is congruent to angle 2?
Yes.
Because definitions can work both ways. They're biconditionals.
Right.
So that means we can say this is again definition of congruent angles. So now we've got AIA, we've got congruent. We're saying that they're parallel. So what's the piece missing here?
We need transverse.
Yes. What's our transversal that ties together 2 and 3?
That's Q.
That's Q.
Sorry.
It's hard to read.
Yeah.
Q is transversal. And what do we call it? What's the reason for that?
Definition of transverse.
Very good. And if we were being a stickler, we'd probably put the transversal prior to calling them AIA, because the reason we call them AIA is because they're transversal.
Okay.
But now we've got all 3 facts, AIA, congruent, transversal.
So we can call it QED.
So now we can say QED. We're done.
Thank you.
Nicely done.